Ladies and gentlemen, today, I want to talk to you about a fascinating phenomenon that takes place on the sun, known as solar flares. You may have heard of these flares before, but do you know what they are and how they work? In this speech, we will discuss the definition of solar flares, their causes, and their effects on Earth. First of all, let's define what solar flares are. A solar flare is a sudden and intense burst of energy that comes from the sun's surface. This burst of energy is usually in the form of electromagnetic radiation, including X-rays and ultraviolet rays. Solar flares can last anywhere from a few minutes to several hours, and they can release as much energy as 1 billion atomic bombs. So, what causes solar flares to occur? The sun is made up of hot, electrically charged gases called plasma. When the magnetic fields of these gases become twisted and tangled, they can create intense magnetic fields that are much stronger than the sun's overall magnetic field. This process is known as magnetic reconnection, and it releases a huge amount of energy in the form of a solar flare. Solar flares can have a range of effects on Earth. The most obvious effect is that they can cause beautiful auroras in the sky. These auroras are caused by the charged particles from the solar flare interacting with the Earth's magnetic field. However, solar flares can also have more negative effects. Now, I want to delve deeper into the topic and explore the effects of solar flares on Earth. As we discussed earlier, solar flares can release huge amounts of energy that can affect our planet in various ways. One of the most significant effects of solar flares is their impact on our technology. When a solar flare hits the Earth's magnetic field, it can create electrical currents that can overload power grids and disrupt communication networks. This can lead to power outages, communication failures, and other technological disruptions that can last for hours, days, or even weeks. In fact, the potential damage caused by solar flares is so great that it has been classified as a significant threat to national security. Governments and organizations around the world are taking steps to prepare for the possibility of a massive solar flare that could cause widespread technological disruptions. But it's not just our technology that is at risk from solar flares. As I mentioned earlier, solar flares can also harm astronauts in space. When astronauts are outside of the Earth's atmosphere, they are exposed to much higher levels of radiation than they would be on the ground. A massive solar flare could expose astronauts to dangerous levels of radiation that could lead to long-term health problems. In addition to the immediate effects of solar flares, there are also long-term effects to consider. For example, solar flares can cause changes in the Earth's climate. When the charged particles from a solar flare interact with the Earth's atmosphere, they can create a chain reaction that leads to changes in the ozone layer and other atmospheric components. This can lead to changes in the Earth's climate that can last for years. The Earth's atmosphere, they can create a chain reaction that leads to changes in the ozone layer and other atmospheric components. This can lead to changes in the Earth's climate that can last for years. Thank you for joining me for this discussion on the effects of solar flares on Earth. As we've explored, solar flares can have a significant impact on our technology, including power grids and communication networks. In this next part of the speech, I want to focus specifically on the relationship between solar flares and electrical power outages, and what we can do to prevent them. To understand why solar flares can cause electrical power outages, we need to look at the way our power grids work. Electrical power is generated at power plants and then distributed through a network of transmission lines and transformers. When a solar flare hits the Earth's magnetic field, it can create electrical currents that are induced into the power grid. These currents can overload transformers and other equipment, leading to power outages. The severity of the outage depends on a number of factors, including the strength of the solar flare, the location of the power grid, and the infrastructure's ability to handle the induced currents. In extreme cases, a solar flare could cause a widespread and prolonged blackout that could last for days or even weeks. So, what can we do to prevent solar flares from causing electrical power outages? There are a number of strategies that power companies and governments can implement to protect power grids from the effects of solar flares. These include implementing protective measures on transformers and other equipment. This could involve installing surge protectors or other devices that can absorb or redirect the induced currents. Developing more resilient power grids. This could involve upgrading infrastructure to handle the increased stresses caused by solar flares, or developing redundant systems that can take over in case of an outage. Improving forecasting and early warning systems. By detecting solar flares early, power companies can take steps to protect their infrastructure before the flare hits. Increasing public awareness. By educating the public about the risks of solar flares and how to prepare for outages, we can reduce the impact of power outages and help people stay safe. While these strategies can be effective in preventing or minimizing the impact of solar flare-induced power outages, they require significant investment and coordination. It's important that governments and power companies work together to develop and implement these strategies to protect our infrastructure and keep people safe. In addition to these strategies, there are also steps that individuals can take to prepare for power outages caused by solar flares. These include stocking up on non-perishable food and water, investing in a backup generator or other sources of backup power, keeping important documents and emergency supplies in a safe and easily accessible location, staying informed about the latest news and updates on solar flares and power outages. In conclusion, the potential impacts of solar flares on Earth are significant and far-reaching. As our reliance on technology and infrastructure continues to grow, the importance of understanding and mitigating these impacts becomes increasingly urgent. By investing in research, improving infrastructure resilience, and taking individual protective measures, we can minimize the impact of solar flares and be better prepared for future events. Thank you for watching, and please consider subscribing, liking, and leaving a comment below to let me know your thoughts on this important topic.